All right, welcome to Chapter 12, Section 1, called Classifying Triangles. This is for Integrated Math 1, or IM 1. All right, so just to get started here on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the gradebook when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. Now we're going to take a look at acute, obtuse, and right triangles. So this is kind of the same idea as when we're doing acute, obtuse, and right angles. So we need to remember what those mean. And what I've been having students do in class with this one is literally draw, and I'll do this with the line tool so it's nice and straight here. So I've been having students draw a right angle like this. So here we have our right angle. This is 90 degrees. So this is where we're starting with, is a 90-degree angle. And I'll put 90 degrees out here for this one so it's not in my way. So a right angle is defined as a 90-degree angle, or it's perpendicular. The sides are perpendicular to each other. So this is kind of our starting point because the other two definitions kind of come right off of this one. As long as we know what a right angle is, then we can define an acute angle. So an acute angle is anything smaller than 90 degrees. So I'm just going to go with blue here like this. And so this is an acute angle. So it's less than 90 degrees. So it's anything less than 90 degrees. So I can even draw the other side of this, which would be the red side here like this. So it's kind of taking that up. So it's this angle in here, this blue one. So an acute angle is anything less than 90 degrees. And then we can go with an obtuse angle. So an obtuse angle is anything greater than 90 degrees, but it has to be less than 180. So it can't go farther than, a straight line. So we have a limit here as far as we can go. But with this one, it would also have an edge over here like this. So we're kind of using that edge over and over again like this. And now I can go from here to here. So it's bigger, it's more than the 90 degrees. So it has the 90 in it and then goes a little farther here, right? So this is kind of an extra area. So obtuse is greater than 90 degrees. It's also less than 180, like I said. So if we were to continue this line over for the angles here, so if I was to continue this over, it can't go past this line. So if we were to draw a line going like this and we try to go all the way around like that, well, that's not obtuse. That's going past the 180. So it does have a limit. We can't go that far. So anywhere, bigger than 90 or greater than 90 and less than 180, because we don't want to go past that linear mark there. So these are the basic categories. And when we're looking at these, when you have an acute angle, and I did acute in blue here, or an acute triangle, so an acute triangle, all three angles are acute. So all three angles have to be less than 90 degrees in order for us to call that an acute angle. So if we come over here and we look at this, the only one, because I have 60, 30, 90, well, that's not less than 90. I have 120 here, that's not less than 90. 60, 60, and 60, this does work. So this guy would be acute. This has a 90 again, so that would not work. If I go with obtuse, which I did in pink here, so obtuse triangle has one obtuse angle and two acute angles. I'll just finish that off there. So one obtuse angle and two acute angles. And this works directly off the triangle sum theorem, because if we think again of a triangle, if we have to add up to 180 degrees and I have something that's bigger than 90, so this angle, whatever it is greater than 90 because it's obtuse, and they all have to add up to 180 degrees, I can't then have another angle that's also obtuse. I can only have one because 90 plus 90 is 180. So if I had two angles that were more than 90, so two obtuse angles, that wouldn't work. I'd have more than 180 already just with two angles. And remember, all three angles always add up to 180 degrees. So this just works directly off the triangle angle sum theorem. If I have one angle that's larger than 90, the other two must be less than 90. They must be acute angles. And we'll go over there and categorize those two in just a second. And then we have right triangle. So this is the same idea as obtuse, except instead of one obtuse angle, it's one right angle and two acute angles. So this is the idea here. And again, this works directly off the triangle angle sum theorem. If I have one 90-degree angle like this, these other two have to be smaller in order for them to all add up to 180 degrees, because I can't have two right angles. If I had two right angles like this, well, that's not going to make a triangle because now I'm already using 180 degrees. So my other angle would be 0, and that's, that doesn't work. That doesn't make a triangle in order to add up to 180. So we can only have one. All right, so over here, I can already see I have a right angle here, so that's a right triangle. I have a right angle here, so again, right triangle. And then this guy here in the middle, this is an obtuse because 120 is more than 90, so obtuse triangle. So it's just about categorizing. We just need to go over those definitions, make sure we know what those three things mean before we move forward. So in this one, it says for each triangle, check all that apply. So we're still classifying triangles in here, which is the entire idea of the section. So we need to take a look and we need to make sure again that we understand, the definitions here. So just to review again, scalene, that a scalene triangle means that no sides are the same. So if we look through these and any sides are the same, then it wouldn't be scalene. So I have 10 and 10, so that doesn't count. 12, 12, 12, definitely not. They're all the same there. 7, 6, 5. So this guy would be scalene. That would definitely count. An isosceles triangle has at least two sides congruent. At least two. It can have more than two, but it needs at least two of them congruent. So I can see 10 and 10. That works. And I can see 12 and 12, or I could go this 12 and 12, or I could go this 12 and 12. It's at least two, so all three does work for that one. And equilateral just means that all three sides are congruent. So this one only has two sides congruent. This one has all three sides. So we check both boxes on this one because it's both equilateral and isosceles. So all equilateral triangles are also isosceles triangles. Doesn't go the other way though. All isosceles triangles are not equilateral because isosceles just means it has at least two sides congruent. And remember with equilateral we have to have all three sides congruent. So just make sure you're paying attention to that definition there. All right, we're going to do number 3. So determine whether a triangle with a given vertices is a scalene, isosceles, or equilateral triangle. I've got my pen here real quick. So what we need to do is we need to use the distance formula to determine this. Because they're just giving us coordinates. I need to know the distance between these coordinates if I have a triangle like this, and I'm not necessarily paying attention to the coordinates here when I draw that triangle. But here I have my 3 vertices, and I need to know what is the distance between T, R, and I. Like this. So I'm just using a coordinate grid to do that. So we are going to need to know the distance formula. So distance equals the square root of the x terms, the difference of the x terms, squared, plus the difference of the y terms, squared. So this actually comes directly from Pythagorean theorem. Sorry, you can hear my dog in the background whining. My kids left her inside and went out and played without her, so she's sad. All right, so with this one, we're going to just take the x and the y's, and we're just going to plug it in. So for t, we have -6 and 4, and for r, so I'm just going to go tr first. And again, this is not me graphing it on a coordinate grid, it's just a visual triangle. Does not mean in any way, and I know these are not in the right spots, because r should actually be on the other side, if I were to look at the coordinates of where those should be. It's just kind of a visual to help me remember to get all 3 lengths here. Alright, so I'm going to have the distance of tr equals the square root of, remember it goes x then y, so we have -6 minus -6. This is a minus already. I don't get rid of the minus because it has a minus. There's one in the equation and there's one in the coordinate here. Plus, I get -2 minus 4 squared. So d equals, I'm going to start to simplify. So this is going to change to a plus. Anytime we see minus negatives, that's a double negative, it turns into a plus. We're basically saying what's the opposite of a negative? Positive. Remember, that's when we're doing minuses, whenever we're multiplying, and when we see 2 back to back, it's multiplication. So whenever you multiply by a negative, you're actually asking what is the opposite of. So that's why it switches to a positive. -6 plus 6 is 0, because they're opposites. And then -2 minus 4 is -6, because they're both negative. I add and keep the negative sign. 0 squared is 0. And -6 squared is 36. So 0 plus 36 would be 36, and I can take the square root of that guy. So the square root of 36 is 6. And then basically when I'm saying what is the square root of a number, I'm asking what number did I multiply by itself to get to that number. So I multiplied 6 times 6 to get to 36. So I multiplied 6 by itself. So, all right, the length of this guy is 6. So now I'm going to go Ri. So R, -6, -2, I is 0, 3. So I have the distance equals, and I would get 0 minus -6 squared plus 3 minus -2 squared. So the distance equals, so this turns into a plus and this turns into a plus, minus negative. So I get 6 squared plus 5 squared. So D equals 36 plus 25, because 5 squared is 25, equals, let's see, what is that going to give me? 11, 5, 6, So 61. So I already know it's not it's not equilateral. It could be isosceles if TI is either the square root of 61 or 6. So it's either going to be isosceles or scalene. We need to narrow that down one more time. So we do have to test all three sides, or not test, but we have to find the distance of all three sides. We don't really have a choice there. Alright, so negative 6, 4. So distance equals 0. Sorry, negative 6 minus 0. I almost wrote that backwards. Squared plus 4 minus 3 squared. Distance equals 36, because negative 6 minus 0 would be negative 6. And 6 squared is 36. So I just went ahead and did that kind of all in one step instead of writing it out like I had been. And then I have 4 minus 3, which is 1, and 1 squared is 1. So I end up with the square root of 37. So all three sides on this are different. So this one is scalene. So we have to go through and we have to do this 3 more times for the next triangle and 3 more times for the triangle after that. So we have to do this a total of 9 times. It's definitely a little bit of a longer process on this one. So my next triangle, I have P, Q, R. So if I'm going P and then Q for this first one, I have 1 and negative 3, and Q I have 6 and 0. So the distance equals 6 minus 1 squared plus 0 minus negative 3 squared. So you can kind of save a little bit more space here. I was writing out all of the steps on those first two, but now, you know, you can do a little bit of the math in your head. So I can go 6 minus 1, that's 5. 5 squared is 25. Plus 0 minus negative 3, that's 3. Because it turns into a positive 3. 3 squared is 9. So this, I would end up with the square root of 34. Square root of 34. Alright, now let's go Q and then R. 6 and 0, and R is 6 and negative 6. So the distance equals 6 minus 6 squared, because I have 6 and 6 here, I forgot my comma there, plus negative 6 minus 0 squared. So now I have 6 minus 6, that gives me 0. So 0 squared is 0. Plus negative 6 minus 0, well that's still negative 6. Negative 6 squared is 36. So this guy is going to be 6, because 0 plus 36 is just 36. And the square root of 36 is 6. Alright, so we know it's not isosceles, or it's not an equilateral. Sorry, I keep saying that funny. Alright, let's go R and P. So R is 6 and negative 6, and P is 1 and negative 3. Distance equals, alright, so I get 1 minus 6 plus negative 3 minus negative 6, because it's a negative 6 there, squared. Alright, 1 minus 6, well that's 5. 5 squared is 25. Negative 3 minus negative 6, remember that turns into a positive. So this, I'm going to subtract, and I'd get 3. It's going to be a positive 3 because 6 is kind of, there's more positive than negative, but really wouldn't matter if it was positive and negative, because when we square it, that kind of gets rid of the negative sign there. So 3 squared is 9, and look, we're ending up with exactly what we did up here. So this is going to be the square root of 34. So this is an isosceles triangle. It's not scalene. There's at least 2 sides matching, so I don't do that. And there needs to be 3 sides for the equilateral. Alright, so let's go through and do this one more time. So now we have D, E, F. So D is negative 1, 2. E is 0, 6. So D equals 0 minus negative 12. Sorry, minus negative 1. I don't know why I said 12. Looks like a 12 there. Losing my crazy mind, that's why. 6 minus 2 squared. So So I get d equals 0 minus negative, that's plus. So I get 1 squared is 1, plus 6 minus 2, that's 4, squared is 16. So I get the square root of 17. That. All right, now let's go EF. So E is 6, 0. F is 1, 2. All right, distance equals, so I get 1 minus 0 squared plus 2 minus 6 squared, and that looks a whole lot like this guy up here. There's a little difference in the plus and the minus signs. So 1 minus 0 is 1. 1 squared is 1. Plus 2 minus 6 is negative 4 instead of positive 4. But again, with that square, it's not going to matter. Negative 4 squared is 16. Positive 4 squared is still 16. So we get that same answer again. So we know it's at least isosceles here. Now we're just going to check that last side to see if it's equilateral. And I wouldn't bank on having at least one of each. Sometimes Alex does that, sometimes it doesn't. I'm thinking that we are going to get an equilateral triangle here, but that's kind of a pattern. You know, I'm thinking ahead on that one. Still check it just to make sure that you are in fact getting an equilateral triangle. Because sometimes Alex doesn't. Sometimes they give you all of the same triangle. I have seen it happen. Doesn't happen that often, but I've seen it where they kind of have the same answer repeated, where you would think that that in itself might be wrong because you're getting the exact same answer each time. But I've seen Alex do it. All right, so I have negative 1 minus 1 squared plus 2 minus 2 squared. So negative 1 minus 1, that's 2. 2 squared is 4, plus we have 2 minus 2, that's 0. 0 squared is 0. So with this one, I want to make sure I did not write the coordinates down incorrectly. I did not. So we get 4 plus 0 is 4, and the square root of 4 is 2. So we do not get an equilateral triangle. We only get an isosceles triangle on that one. So they didn't do equilateral at all. Alrighty, so that was section 1. I will see you in section 2.